Hello everyone, just want to come to you today with a polar graphing lesson. So you have always been graphing XY points, right, on a rectangular XY coordinate plane, right? You go left X amount, you go right X amount, you go whatever you do for the Y and you get that singular dot. Today we're looking at a graphing called polar graphing, right? So it's on a flat plane just like rectangular, but it's a little bit different as to where we put the points. Okay, so if we have point P, which is right here, right, it's in the plane, and it can be described by giving its distance from a fixed point called O. Now, this dot should be there, right? That is the pole, which, for the most part, we're thinking about it kind of as the origin, that 0, 0, that center spot. That's the pole that we are rotating around. We have our fixed polar axis, and from that polar axis, we rotate around theta amount of degrees to get to our point. And so every polar point is going to be r comma theta, meaning how far from the origin or the pole and how many degrees do we rotate around to get there. So if we look at this, right, here's our polar axis right there on that 0 degree line. All right, so the idea is for 3 pi over 6, right? Pi over 6, we're here. We're on this line. Here's our pole. We are going 1, 2, 3 from that pole, right? So right there, that's our point 1, that 3 pi over 6. We rotated up pi over 6 degrees, or radians, to get to that line, and then we went 3 away from the pole. Right, so 4, comma 3 pi over 4. Right, 3 pi over 4 is there. So we're rotating all the way around to that line. Then we're going 1, 2, 3, 4 from the pole. Right, there's our point 2. All right, 5 pi over 3. We're rotating all the way around to over here. Right? And we go 1 unit, 1 radii away from the center, the pole. All right, so listen, everything we have here, you could add an XY axis and kind of mathematically figure out where those points fall on a coordinate plane. We're going to do that later, but we're graphing based off this distance from the center and degrees rotated around. All right, so we got 3 other ones to graph here. All right, so first thing first with this first problem. All right, it's larger than 360 degrees. All right, so I could do coterminal in these situations. All right, so with coterminal, we add or subtract 360, or we add or subtract 2 pi, depending on our situation. So if I take 13 pi over 6, and I subtract 2 pi, that'd be 12 pi over 6, I get pi over 6. So in this situation, this is the exact same thing as 3 pi over 6. Okay, so nothing new to graph here. Point 4 is the same thing as point 1. They're the exact same thing. So anytime you have something outside of 360, you can add or subtract 360. You get those coterminal angles on the inside. All right, now for 5, we have the scenario where we have a negative r. All right, so 7 pi over 4. 7 pi over 4 is here. Right, so we're obviously not going to go from the pole down that line because we have the negative. So we go to the pole and we go the opposite. And by going the opposite, guess what? Negative 4, 7 pi over 4 is the exact same thing as 4, 3 pi over 4. Right, so a negative r leads to this. If you don't want to work with the negative r, if you take the absolute value of the negative r, you could take the theta and either add 180 or subtract 180. Right? So that's what happens here. Right? We changed a negative 4 to a 4. We took 7 pi over 4 and we subtracted 4 pi over 4, which is 180, to get 3 pi over 4. Right? So someone earlier asked me, like, when do you add 180? When do you subtract 180? My method with the 180s is I add or subtract 180 to make sure it's between 0 and 360. I don't want the angle to go outside those two things. All right, so if we look at this one, all right, first thing first here, for problem 3. Well, just making it be known that these are the exact same thing. So for problem 3, I don't want to work with the negative 5 pi over 3. So if I add 360, I get negative 1, and I add 6 pi over 3, I get pi over 3. So I could graph at pi over 3 and go the opposite direction. So pi over 3, the opposite direction would take me there. But just talking about the other option, if I want to make it a positive one, I have to add 180. So I add 3 pi over 3 for 4 pi over 3. They're all the exact same thing, right? Whatever way you do it, it's fine. It's going to get you there, right? You could graph with a negative angle. You can graph with a negative r, or you can make them all positive and have them between 0 and 360. Okay, so the other thing we got to talk about here is converting between the two. Right, so as I said, obviously you can graph 2, 2. 1, 2, 1, 2, there it is. That is a rectangular point that we're graphing. But we can figure out a way to mathematically come up with what's the r and what's our theta that we rotate up to. Right, so we rotate up to there. And what we do is what we've always done. We can make a triangle. And our triangle has a 2 up and 2 to the right. So how do we find r? Pythagorean theorem. 2 squared plus 2 squared equals r squared. R squared equals 8. R equals rad 8, which is 2 rad 2. Right, it's 2 rad 2 away. And that's consistent. To find r, given an x and a y, is the square root of x squared plus y squared. All right. How can we find theta? Well, guess what? We have SOHCAHTOA right now. And we could do tan. Tan theta equals y over x. Tan theta equals 1. Now, we don't have to do inverse tan of 1 to get the answer. We know what the answer is just by our unit circle. Where does tan equal 1 the first quadrant? 45 degrees. So our point here is 2 rad 2, comma 45 degrees, or pi over 4, whatever you want. But if it's not a unit circle, to find theta, inverse tan of y over x every single time. All right, what about the reverse way? All right, so I go in pi over 6. Pi over 6 is 30 degrees up, we know. And I'm going 3 units away. All right, so there's my 3 pi over 6. I went 30 degrees up, and I went 3 units away. All right, so again, everything relates back to the fact we can make a triangle. I could draw my triangle there. I know my radius. Right? I know my left angle. My left angle is 30 degrees. So I could solve for x, I could solve for y in this situation. If I want to solve for y using basic SOHCAHTOA, I could do cos of 30 equals adjacent over, I'll be solving for x right here, equals adjacent over hypotenuse. Right, so x equals 3 cos 30. All right, what's cos of 30? Right, we know cos of 30. Cos of 30 is rad 3 over 2. So this becomes 3 times rad 3 over 2 for 3 rad 3 over 2. If I want to solve for y, sine 30, y over 3, y equals 3 sine 30, y equals 3 times a half for 3 over 2. So the rectangular point that we have here is 3 rad 3 over 2, comma 3 over 2. And this consistent method works every single time. X is always going to be r cos theta. Y is always going to be r sine theta. Every time. All right, so if we look at some examples here. Converting between the two. All right, I got x comma y, so r equals the square root of 3 squared plus 4 squared. R is 5. All right, I need my angle, so I can do the inverse tan of y over x. So if I do inverse tan of 4 divided by 3, I get 53.13 degrees. So my polar point is 5, 53.13 degrees. I am 5 units away from the center, and I rotated 53.13 degrees away. All right, r equals the square root of negative rad 3 squared plus 1 squared. R equals the square root of 4, which is 2. Inverse tan of y over x. Inverse tan of 1 divided by negative rad 3. I get negative 30 degrees. Well, the real idea here is we're in the second quadrant, so negative 30. I got negative 30 degrees. Right, but that doesn't make much sense because I'm in the second quadrant. So that just tells me since I'm in the second quadrant, because of a negative x, positive y, that tells me that I have 150 degrees because my reference angle is 30 degrees. Right, so we have 2, 150 degrees in this scenario. Right, the negative 30 is a little fishy, but really it's giving you the reference angle, and we know we're in the second quadrant. All right, x equals 2 cos pi over 4. 2 times rad 2 over 2 for rad 2. Y equals 2 sine pi over 4. 2 times rad 2 over 2 for rad 2. So our rectangular point here is rad 2 over 2, comma rad 2 over 2. X equals 4 cos 4 pi over 3. All right, so we're talking 4 pi over 3. We're talking 60-degree reference angle in the third quadrant. So cos, we got that negative a half. 4 times negative a half is negative 2. Y, 4 sine 4 pi over 3. 4 times negative rad 3 over 2 for negative 2 rad 3. There's our point.